Assalamu alaikum. This is our project Aesthetic Fault Identification of Products through Image Processing. So in this presentation, we have gathered the information of the requirements of the project and we have accumulated in this presentation and we'll be presenting this. So firstly, what's the problem statement? So currently what we saw was that current manual inspection methods in manufacturing are prone to human errors and inefficiency in detecting aesthetic defects, leading to inconsistent product quality and reduced customer satisfaction. There's a need for an automated system that can accurately detect aesthetic defects in real time, ensuring consistent quality, reducing human error, and enhancing overall customer satisfaction. So the aesthetic appearance of the product is very appealing and necessary in terms of production because that's the thing that's directly in the sight of the customer, and that has a lot of impact. Even if a thing is not functioning properly from the inside and is presented well, so a customer can somehow approve of that product rather than a product that has a bad aesthetic or some visual defect in that. So our mission statement for this project is that to develop an automated system using image processing to detect aesthetic faults, enhancing product quality, minimizing human errors in production, and standardizing the process. So just making it more feasible for the industry as well as for the people that are involved in the process. So we'll kind of automate the system that is currently being used, that is being done by humans. So the key insights and key themes are that system must detect minor faults, scratches, dents that are all included in aesthetic faults, scratches, minor defects, reduce reliance on human inspection. So what we saw currently was that all the quality check was done through human inspection, and we look forward to automate that process through image processing. Furthermore, enhance real-time feedback for corrective actions. We'll come onto that in detail. The key themes are defect detection and system accuracy, quality control and efficiency, and systems adaptability and real-time feedback. That is very necessary for our system. So Abdullah will continue from context diagram.
Hello, Assalamu alaikum. So, this context diagram basically depicts the entire process or the the system, the larger system, where our subsystem of the aesthetic fault detection mechanism will be placed at. So, if you see, we have like these main entities; those are supposed to interact with our system. So you can see we have the sample, the boundary sample, which would obviously be used by the human operator or the inspector, इंस्पेक्टर स्लैश क्यूए टीम का कोई भी बंदा होगा जो हमारे पास बाउंड्री सैंपल को यूज करके यूटिलाइज करेगा within the system. So the system will then check for any aesthetic faults in the mold, uh, and we also have this centralized facility role, the positioning area or the place where our subsystem will be placed at. So it should provide some facility or some, some room, some space for the operator to operate at, or the QA person to inspect how the results are going on. And yeah, so this is the larger picture of how our system would interact with the external entities that it is supposed to interact generally. So let's move on to the next. So those earlier entities are, we can now depict them in this process flow diagram. We also discussed this in our earlier industry visits. So you can see that the users in this, we like subdivided the user into the operator, the inspector, and the quality assurance person. So currently what is happening is that most of these tasks that are in the system, uh, row are currently handled by the operator or the supervisor. But now what will happen is that we have this system row which is entirely separate. It is completely independent of, not completely independent, but to some extent independent, and is operating on its own to so it is removing that human dependency wala part, uh, in which the supervisor or the operator needs to check all those aesthetic faults. So initially what was happening is that the operator had to do all these checks, or the supervisor had to approve the boundary sample. But now what will happen, you can see that first the operator receives the sample. It will then place the sample into the system. The system will then uh, start the process. It will firstly make sure that it is positioned correctly. Then if it is not, then it will like require the operator to at least make sure that it is positioned correctly. Then it will move on the checking part. So here it has two choices. Either it will be used as a reference, but so it will be used as a boundary sample. For that, the system needs to be like given an input that it we are like making it a boundary sample or any other sample, or overriding an existing sample. In the case of overriding, it would require like special privilege from the supervisor. The supervisor will instruct or set up the system to get the uh, reference sample. So either we take the reference sample or we check against the reference sample. In both cases, the system will then continue on taking the pictures from all angles, all six angles. The rotation platform will rotate and the system will take picture. It will then utilize the algorithms and the image processing to do the work, and lastly, it will give a final result whether it is a faulty or a non-faulty sample. Uh, After that, the we have three again the users. It is the role of the user supervisor or the quality assurance person. They can check if the results are accurate or if it needs to be improvised in. So currently our system has the flexibility, so the supervisor can that overriding flexibility of overriding a sample in case if there is any fault that is not being detected, or uh, the supervisor wants that to not be detected. In that case, we will go again and uh, treat that as a boundary sample. In that case, if we want to utilize a new boundary sample, or we want to make sure that the new reference is treated as a boundary sample. So if that's the case, then that is set as a boundary sample. Or if it was not a boundary sample and was being checked uh, against the boundary sample, in that case, our system will simply terminate. And yeah, that will complete this process for now. So yeah, that's it from my end.
Okay, so now let's talk about how our system will work in real world scenarios. So basically, our system focuses on detecting aesthetic faults by capturing and analyzing product images. This includes uh, faults like scratches, gas marks, and burn marks, uh, which are often missed in manual inspections. Other than that, we will integrate pressure sensors and weight-based checks to ensure proper molding and product consistency. Uh, Also, to maintain quality, as we discussed, we use boundary samples, which are essentially reference models for each batch. This helps in setting a standard for defect detection. Also, in cases where minor defects are unavoidable, the system allows for an override mechanism, so products aren't unnecessarily rejected. As you can see uh, on the right, हमारे पास अभी एक इमेज है करंट डिफेक्ट डिटेक्शन की. एंड हमने एक नीचे से एक जो हमारा आइडिया है जो हम इम्प्लीमेंट करेंगे वो बनाया है। तो देयर इज दिस करंट डिफेक्ट डिटेक्शन जिसमें मैन्युअली ह्यूमन डिपेंडेंसी है, और एक हमारा नीचे है जहाँ पे हमें जानने जो हमारा अल्टीमेट गोल है। देयर इज अनदर इमेज जिसमें एस्थेटिक फॉल्ट दिखाए हुए हैं, जो कि लाइक जो कि लाइक देखने में अच्छे नहीं लगते। तो यूजर यूजर की इमेज फॉर द प्रोडक्ट एंड इट्स क्वालिटी वो भी कॉम्प्रोमाइज होती है। उसके अलावा वी हैव दिस बाउंड्री सैंपल जो कि हम रेफरेंस एज अ रेफरेंस यूज करते हैं ताकि हम बाकी के भी मोल्ड चेक करें। गोइंग टू जस्ट गो टू नेक्स्ट स्लाइड। फ्रॉम हेयर वासे विल कंटिन्यू।
Assalamu alaikum, everyone. Now we are going to discuss the goals and key outcomes. So basically, our project aims to enable real-time fault detection for immediate identification and intervention during production. It will be adaptable to various part sizes, making it flexible across all product range. The system will provide accurate fault identification with minimal false positives, ensuring reliable results. मतलब 99% it will detect the faults. It will also improve over time. It will be like machine learning ke through. It will improve as time goes on, and it will enhance its detection capabilities. Additionally, the system will offer integrated decision making for corrective actions and real time alerts for enabling quick response if faults occur. The system is also designed to be scalable and will work seamlessly across multiple production lines. It will also localize defects, pinpointing the exact location for more efficient inspection. On the right, you can see some of the parts that uh, first we can see the black washing machine base part where which is I think yeah, it's a fault, and our system should be able to detect that fault and in real time also send an alert so that fault can be processed. And as Moshe told, the boundary sample is also there, and you can also see the size of how small the faults can be, and our system should be able to detect them. uh, so now moving on to the system functionalities, Bilawal will take over from here.
Assalamualaikum. Okay, so for now, the system functionalities, we have basically come up with a few functional requirements, and we'll discuss them right now. So basically, our system's primary goal is to automatically detect the defects in product using the image processing technique. This image processing, the idea of image processing and vision will basically reduce the human inspection, will reduce the human error, and which are usually consistent in the systems. And so basically the system will replace manual inspection. The system will also capture and analyze the product. So system will automatically capture the images from all six sides of the part, and which will provide us a comprehensive inspection from all the parts of the part from all the angles, and which will ensure that there are no defects and which are we have missed. For the dimensional measurement, as we discussed with Dr. Sarmansur in the previous meeting, that our system should be able to uh, do the dimensional check, as it's usually missed during the manual inspection. So our system, as discussed previously in the meeting, that our system will check the dimensions of the product, and it will verify that it aligns with the master or the reference sample which we are checking it against. And it will help us to ensure that there are no discrepancy in the size or the shape of this product. For the defects, our system, when detects a defect, the system will classify the defect either a minor or a major. So it will basically be on a predefined threshold, which will be set or which will be predefined in the system. So we can use that to check either like we also discussed that there should be a 0.01 millimeter discrepancy or 0.01 millimeter error check. So any minor error that the system shall detect, it should uh, immediately should tell the user or the operator. And there's another thing that we came up or that we got from the meeting was that the boundary sample management. The the operator or the user, whenever a boundary sample is either a defected piece or it's basically not exactly how the reference or the master sample is. So the boundary sample the system should be adaptable to the new boundary sample. So the system will allow the user to designate the updated boundary sample, and that boundary sample or the reference part will help the system to identify what constitutes as a defective part, depending on the new boundary sample that we have provided. Moving on to the next. For the specifics of our system, like more of like in the technical terms, are how the system should do all that we've discussed right now. So basically, the system will use the high resolution image processing, which will give us the more detailed picture of our product, and which will make sure that we do not miss any sort of defects that are visually or aesthetically detectable. uh, Weight related defect detection too, like our system should also have should check the weight of the product or any part that we are checking. So basically, as discussed, the weight is also a factor in the accuracy or the basically mm, the quality of the product. So a weight check should be there in a system, and it will detect the defect based on that weight sensors. Uh, the system will basically also pinpoint exactly where the defect is. So after the defect detecting a fault, the system will provide the localized information of where exactly that defect is, and that will make the task easier for the operator to know and identify where the defect is so that they can rework or make the rejections, whatever the case is. For the dimensional discrepancies, the system shall detect the dimensional discrepancies. Uh, it should it should ensure that the parts are made to the correct dimensions, comparing to the reference sample that we provided or the boundary sample that we have given to the system later on. Okay, so that's from us. These are basically the technical requirements or technical adaptabilities of the system. So for if there are any details or any feedback that you would like to give us, or are there any questions that you have about the presentation, about the requirements, or about the complete process, please share with us. Or if you can, yeah, that's it from our side. Thank you.